All right, welcome back, boys and girls. To find the vertex of the graph of a quadratic function in polynomial form, compare the transformation form to the polynomial form. So first, we multiply and distribute the terms in the transformation form, so the coefficients can be compared. What that means is I'm going to need some space here. So first I have to multiply this x minus h squared out, which means this is x minus h times x minus h. So that would give me a times x squared, and then it's minus hx minus hx, so that's 2hx. And then plus h squared, because it's a negative h times a negative h, plus k. Yes, Felicia. Okay, so now we have to multiply a by each of these terms. So I have to distribute the a to each one. That gives me ax squared minus 2ahx plus ah squared plus k. If I'm grouping things together, I can group the ah squared plus k because there's no variable with those. If we're thinking about actual numbers, within a problem, the h, the k, and the a are all just numbers. The x's are only actual variable. So these things would be our constant. That would be our c. And then if I'm looking at here, I have negative 2ah, and polynomial form was ax squared plus bx plus c, so this is what our b would be equal to. B equals negative 2ah. Now I can solve for what my h would be, because that would be the x value of the vertex. So in order to solve for that, I would divide both sides by negative 2a. That means that on my right-hand side, all I have is my h. So h is equal to negative b over 2a. So that gives me the x value of my vertex. Then to find the y value, I would plug this into my function everywhere I see an x. So my actual vertex is negative b over 2a, and that point plugged in to the function. Wait, what? This part, my h value in this equation, which is the x value of my vertex, is, we did all of this just to solve what that b value was, because if I'm looking at my form, my polynomial form, b is the middle number that's with the x. So the number that's with the x down here has to be equal to b. We know that h is the vertex, so this negative 2ah is equal to the b. And then we solve for b, or solve for h, knowing that h is the x value of the vertex, and that gave us that the x value of the vertex is negative b over 2a. Then to find the y value of the vertex, you take whatever this is and plug it in. All of that was to show you how to compare the vertex form with the polynomial form. So for the function f of x equals x squared plus 2x plus 3, if I need to find the vertex in the x and y intercepts, sketch the graph. Then to find the vertex, I know that the vertex is hk, right? And that was in the vertex form. And I just learned from my last slide that h equals negative b over 2a. So if I'm trying to find my vertex, in order to find what the x value of my vertex is, I just need to plug in some numbers here. What goes in for negative, well, what goes in for b? Our polynomial form is ax squared plus bx plus c. So 2 goes in for b. So that's a negative 2 over 2, and what's a? A is 1, because there's no number in front of x squared. So it's negative 2 over 2 times 1. 2 times 1 is 2. Negative 2 divided by 2 is negative 1. So that gives me the x value of the vertex. That's negative 1. To find the y value of the vertex, I need to plug that negative 1 in everywhere I see an x. So f of negative 1 equals negative 1 squared plus 2 times negative 1 plus 3. Negative 1 squared is 1. 2 times negative 1 is negative 2. 1 minus 2 is negative 1, plus 3 is positive 2. My y value is 2. Now I have the vertex at negative 1, 2. To find my y-intercept is always in polynomial form, just the number that's my c value. So my y-intercept is 3. It's whatever the c value is. Lastly, we have to find the x-intercepts. If you remember from yesterday, to find our x-intercepts, we do this formula. All right? Before I do that, I'm always going to check what's under my root. My formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Before I actually solve it, I'm going to figure out what b squared minus 4ac is from our equation. You know what b, a, and c all are, right? b is 2, a is 1, c is 3. So if I'm doing the b squared minus 4ac portion, b squared is 2 squared minus 4 times 1 times 3. It gives me 4 minus 12, which is negative 8. Can I take the square root of a negative number? No. It would give me an imaginary root, so there are no x-intercepts. No. Then we could finish solving it out. Take the square root, plug it into the rest of the formula, and solve it. Right. Yeah, because if this would have ended up being positive 8, well, now I just know what's under the root, and it would be negative 2 plus or minus the square root of 8 over 2. So you would just solve that out. In this case, though, we ended up with no x-intercepts. Our last step is to graph it. And given the basic information that I have, I can graph this. I have that my vertex is negative 1, 2, and my y-intercept is 3. So if I go back to negative 1 and up to 2, that's my vertex. My y-intercept is 3. So to get to here, from my vertex, I went over 1 and up 1. So I can go the opposite direction, knowing it's a parabola, left 1 and up 1. And that's going to give me another point. So I can finish out my basic sketch of the graph. By the way, your line should go through that point. And so there's my basic sketch of a graph. So that's polynomial form. Next we have x-intercept form. X-intercept form is most useful for finding the x-intercepts. Who would have guessed? Any quadratic function written in x-intercept form, f of x equals a times x minus s times x minus t, and there the x-intercepts are just s and t. To find the y-intercept is always where my x is 0. So if I just plug that in, that gives me a times 0 minus s times 0 minus t. It gives me a times negative s times negative t. Since I'm multiplying two negatives by each other, that's a times s times t. So to find my y-intercept, it's a times s times t. Yes. Then to find my vertex, the vertex is just going to be the average of the two x-intercepts, because the vertex is going to be directly in between them. So if I take my two x-intercepts, which are s and t, add them together and divide by 2, that will give me the x value of my vertex. And I just plug it in to find the y value. All right, I'm going to pause today's lesson right there because someone has specific requests for the homework. Okay, number 1 from the homework, it was 3 times x minus 5 squared plus 2. The first thing it tells you is determine the vertex of the given quadratic function and state whether it opens up or down. Well, since this is vertex form, that means it's in the form of a times x minus h plus k. And if we look back at our notes, squared plus k. If we look back at our notes, and we look at the transformation form, that's what form these are in. It says the vertex is the point with the coordinates h and k. So all I need to do is look at my number 1. H is this number here, and k is this number here. So my vertex is 5, 2. Done. No, it's opposite of h and positive k. So you change the sign of the h and you keep the k. And it's because it's a negative in the formula. So it would be minus whatever my h number is. Say whether it opens upward or downward. If it's a positive number out in front being multiplied by it, it's upward. If it's a negative, it's downward. What? So if it was x plus 2 minus 5, then your vertex would be negative 2, negative 5. Switch the sign of the h every time. Whatever's in here, switch that, keep the k. Looking at number 5, it says determine the y-intercept of the given quadratic function and whether it opens up or down. These are all in polynomial form, so your y-intercept is the last number of every one of them. That's it. Say whether it opens upward or downward. Look in front of the x squared. If it's positive, it opens upward. If it's negative, it opens downward. Yes, we did. See how the 3 is circled? It's a positive 3, so it opens upward. This one, number 13, says determine the vertex and the x and y intercepts of the given quadratic and sketch a graph. So to determine the vertex, this is in transformation form, which means I have my vertex already. It's going to be switch the sign of the inside number, so it becomes negative 3. Keep the sign of the outside number, that's negative 4. That's my vertex. Then if we look back in our notes from yesterday, looking at transformation form, it says to find the x-intercepts, I do my h plus and minus the square root of negative k over a. h. So my x-ins is the h, which was a negative 3, plus and minus the square root of negative k, so that's a negative of a negative 4, over a, which is 2. 4 over 2 is 2, so it's negative 3 plus or minus the square root of 2. Those are my x-intercepts. Find my y-intercepts. It's f of 0, meaning I just plug a 0 in for x. So that's 2 times 0 plus 3 squared minus 4. 0 plus 3 is 3. 3 squared is 9. 2 times 9 is 18. 18 minus 4 is 14. That's it. Doing this